So the next lesson in measurement is our lesson on uncertainty. So what is uncertainty? Let's discuss that first of all. We've already talked about the precision. The precision of a measurement is restricted by the limitation of the measurement scale. Okay? We talked about that in the unit on, or the lesson on precision. Depending on how finely marked something is will depend on how precise we can be. Okay, if the smallest division or marking on your ruler is millimeter, you can only make a measurement to the nearest millimeter. Okay, I don't know if that makes sense to you, but let's pretend this is a ruler here. Let's take a section of a ruler. And let's say, I don't know, maybe this is 4 and this is 5 centimeters. Okay, and let's say we only have this marking here. Okay, this would be 4.5 centimeters. Well, if we take an object and let's say it ends up going right here. Let's say this object is that long. Okay, what would we say the measurement is? We would say this is 4.5 because it's closer to 4.5 than it is to 4, and really we can't we don't know for sure what the measurements are there. We don't know what the increments are. Okay, so when we have precision, that's what we have to use for our measurements. Now if I had those markings like that, now I would say, okay, that's 4.4 millimeters or centimeters, sorry. Okay, so it depends on how precise the object that we're measuring with is. All right, if you look at this thermometer here, if you measure temperature using a thermometer shown below, this one, how precise can your measurement be? Okay. Would you estimate a more precise measure? Well, let's take a look at the outside numbers, these ones here. Okay, the bigger numbers, those are degrees Fahrenheit. So you can see it goes up to 120, but what's more important for precision is to figure out how many lines you have in there. Okay, if I kind of zoomed in between, say, 50 and 60, how many lines are there in between there? You can see that there are only, I think, 4 lines. Okay, so what would that mean each of those lines represents? Well, if we divide 50 like that into 5 zones, that means this would be 52, this would be 54, this would be 56, 58, and 60. So when I see that arrow aimed here, based on how many lines there are, I think that's 72 degrees. Okay? I don't know if it's 71 or 73 because I don't know what's going on between those lines. I have to pick the nearest marking and go with that. So what is the precision in this case? The precision is to 2 degrees Fahrenheit. Okay. Now if I looked at the inside scale, this one here, you can see that it goes up by tens with only 1 marking in between. So in this case, for example, if we went from 0 to 10 degrees, that only gives you 1 marking. That's got to be 5 degrees. So the precision is 2 degrees Fahrenheit or 5 degrees Celsius. The inside scale is Celsius. Okay? So because the precision of a measurement depends on the limitations of the measuring device, there is some uncertainty. This is what our lesson is on, uncertainty. We're not quite sure what's going on between the markings on the whatever scale we're using. Okay, and the uncertainty is going to be half of the smallest scale, in other words, half of the precision. So, going back to our precision here, if our precision is 2 degrees Fahrenheit, half of that, half of 2 is 1. So the precision is plus or minus 1 unit, or 1 degrees Fahrenheit. Okay? So let's see if we can go a little further here. A measured value can be written as followed. Okay, so I'm going to give you an example right away, but it's the measured value plus or minus the uncertainty. So let's deal with that one we just had. It was, the measurement value was 2 degrees, or sorry, for the, 72 degrees. We measured with that thermometer, it was 72 degrees plus or minus 1 degree. Okay, and this is half of the precision, and our precision was 2 degrees. Okay, so looking at this example, we say the precision is 2 degrees. We look at that measurement, we say it looks like 72 degrees, but because there is some uncertainty there, it could actually be 71, or it could be 73. It could be anything between 71 and 73. That's what this means. It's 72, could be plus 1, which would be 73. It could be minus 1, which is 71. So in other words, this is what it means is it could be anywhere between 71 and 73 degrees. Okay, so let's try a couple of examples. Beatrice is a baker and is measuring milk. She uses a measuring cup that is precise to 1 fluid ounce. The recipe calls for 8 ounces of milk. What is the uncertainty in her measurement with a number? Okay, rule of thumb is that the uncertainty is in a single measurement is half of the quantity between scale markings. Okay, so what is uncertainty? Uncertainty is half of the smallest scale interval, or the smallest unit of measurement. Okay, the smallest scale interval in this case is 1 fluid ounce. So our uncertainty would be half of that, half of 1, which is, if you use your calculator, you're going to get decimal 5. You could put it as half or decimal 5. Okay, and in this case, it's fluid ounces. That's your uncertainty. Okay, let's try another one. A baker sets an oven timer that displays 1-minute increments. Okay, 1-minute increments is my precision. So the precision is 1 minute, or minutes. Okay, so what is the uncertainty? Uncertainty is going to be half of the precision. So this again is 0.5 minutes. Okay, and I guess I should have put plus or minus. It could be, 0.5 too big, or it could be 0.5 too small. Okay, try the next one. A nurse measures a patient's temperature to be 36.8 degrees. There's my precision. The precision is 0.1 degree Celsius. Okay, so then what's my uncertainty? My uncertainty is going to be half of that. Okay, plus or minus half of, now it's 0.1, so if I go half of 0.1, it's 0.05. Okay, so what that, it doesn't ask for this, but what this means is this measurement is 36.8 plus or minus 0.05 degrees Celsius. So that means the actual temperature could be 76.75 to 36.85, somewhere in that range. Okay, because if we looked at a scale and we saw that it was 36.8, it could be a little bit bigger or a little bit smaller than that. Okay, Let's look at this one. What is the precision? The precision is 0.001 grams. Okay, so my uncertainty would be half of that, so that would be decimal 0.0005 grams. Okay, and it's plus or minus. Okay. Alright, so this is a little bit trickier one. Ian is packing for a camping trip. What is the combined weight of camping equipment to be packed? Well, let's add it up. If I combine the weight, if I add these all up, by the way, notice they're not all in grams, so we do need to change that first. Okay, so let's change the weight into grams before I can add them up. So this is still going to be 392, this is 143, but 3.8 kilograms is 3,800 grams, and 1.2 is 1,200. So now if I add this, I get 5,535 grams. That's the weight that this person is packing. Okay, let's now consider the precision in each measure. Okay, so we looked at each weight. Let's look at each precision. So the precision for the first one is 1 gram. That's the smallest unit given. The next one is also 1 gram. Okay, but what is the precision here? It's 0.8 kilograms, which is actually 100 grams. Okay, so that's the unit of measurement that is the most precise. And same with this one. Okay, so what is the uncertainty? So this one is plus or minus 0.5 grams. This one is plus or minus 0.5 grams. This one is plus or minus, what's half of 100? 50 grams. This one is plus or minus 50 grams. So, when I look at this total measurement, it's 5,535 grams plus or minus, let's add up the uncertainty. You end up with 101 grams. So that's what the uncertainty is here. Okay, we kind of look at the extremes. What's the most it could be? It could be 101 grams too heavy or 101 grams too light. Okay. So, I mean, this is might be a bit of a strange lesson to you. I don't know if you have ever measured with precision like that. I know I never do. Okay, so it definitely will be something to get used to. I would like you to try the homework, and we will discuss it in class.